Okay, hi. The next problem posted in the group was this: an ideal gas contained enclosed in a container of volume V and pressure P. It is being pumped out. Okay, so first ideal gas is there in a container of volume V. Pressure is P, initial pressure. Okay, this is the volume of the container. It is being pumped out of the container by using a pump. So you have a pump attached to it. So let's say this is the pump, and the job of the pump is to pump out the air. Okay, air is pumped out. This is the pump with the stroke volume V. Okay, stroke volume V means, for example, let's say the pump operates once. How much air will it remove? It will remove an air in, for example, a small portion of this full container. It will not fully suck out, right? So it removes a small portion. Whatever gas is present in this part will be sucked out. This portion is removed. Again, remember, only the what is that? Air in this portion is removed. The actual volume of the container cannot change. Okay, so this is volume V. That is the portion that is removed is small volume V. This is capital volume. And once it has been removed, you need to understand. Let's say it is operated only once. So what will happen? This portion of the air is removed. The remaining gas will still occupy the same volume. So you need to understand, every time the pump is used, the gas is getting removed. So what is getting removed? Number of moles is removed or changed, or mass is removed. The actual volume of the container will never change. So if I pump some air out, the remaining air will still occupy the same volume V. You need to understand that. I turn on the pump, use it once, turn it off. The remaining gas that was present in this portion now occupies the full portion. Okay, so the number of moles has changed, but the actual volume of the container will not change. So we need to understand for the entire process. Okay, temperature they have said it's constant. You also need to recognize that volume is constant. First, understand that clearly. Okay, so removes portion V means it's not changing the volume of the container, it's changing only the amount of gas inside. So V and T is constant. So we know that PV is equal to nRT. V, R, and T are constant. So P is directly proportional to N. That's a key idea here. And final pressure. So which means we want to find the final pressure. I want to find the final number of moles, obviously. Okay. We can do it normal. Let's say, let's do it step by step. So for first stroke. Okay. So now I'm going to use the pump for the first time. Initially, okay, I'm going to write down the number of moles present. Moles present, and then the volume it occupies. Initially, the total, before the pump is turned on, the total number of moles, let it be N, and it occupies a volume of V. What will be removed of is this portion. Okay, and what is left? Let me say the left is here. Let's call it as N prime. And how much will be here? N minus N prime. You need to understand, the portion that is removed is N minus N prime. What is left is N prime. That's the symbol we are taking. So left is N prime. And what is the volume it is occupying? Remember, after this process over, it will eventually occupy the full volume. Don't get confused. Now, what is the portion that is left? The amount of gas in this volume will be left, whereas in this portion will be sucked out. So what will be left is the volume of the gas or the amount of gas in this volume. What is this volume equal to? It's the total volume minus the volume of the gas that it sucks out. Okay, understand? So it is initially total volume is this, and now this portion is left off and remaining is gone. Okay, and since they are directly related, so I can simply, we have done this many times, you can either cross multiply and equate or divide and equate. So if I cross multiply and equate, so N into capital V minus small v, it's N prime into capital V. So N prime is N capital V minus small v by capital V, N prime. So N into, I mean, let's have it like this, then over. So this is the number of moles. Understand the logic? Number of moles is decreasing. So numerator is less than the denominator. So that clearly shows number of moles is decreasing. That's also logically what is happening. Right. This is after the first stroke. And once the first stroke is over, understand what will happen? This blue region of the gas is sucked out. Now let's say the pump is turned off. What will happen? This N prime portion of the gas occupies the full volume. Pump is turned off now. Okay, just to see one stroke, if it works, what happens? Okay, now I'm going to turn on the pump for the second time. So let's say second stroke. Again, same thing, let's write down. So I'll say moles present and the volume it occupies. And look at this, how much is the moles present in prime, and it occupies the full volume. Understand that clearly. Now again, what is the portion that will be left off after it operates once? Use a different color. Okay, so let's say this portion will be sucked out, and what is left off is n double prime. Let's assume that what is left off is n double prime. It use the same color, n double prime. And what volume will it occupy? Same thing. The one that will be left off, that is not sucked, will be in this, any gas in this portion will be left off, and this is sucked out. So what is the moles that is left in the cylinder while the pump is working? It is V minus V. I hope you understand. Again, because this portion is removed, this portion is left. Again, same thing. Look at this. Everything is same except for you have added a prime. Okay, n becomes n prime becomes m double prime. So if I do the same calculation, I'll get the same thing. N prime will become n double prime. N will become n prime. Nothing else will change. If you want to just do the full step, I don't have the space for it. Okay, right. Now, what I have to do is I have to substitute for n prime. Okay, and then this one, if I substitute that, I'll be getting n into capital V minus small v by capital V times this. You see, this n prime term I have substituted here. This is left off. Okay, so when I multiply this term again, you can see clearly it's getting a square. I don't have space, I'm just explaining this stuff. This is the number of moles. And again, you see numerator is less, denominator, and it's getting lesser and lesser. That's what the pump does. It's sucking the air out. So number of moles decreases. And look at the pattern. So we see a pattern, we identify a pattern here. After first stroke, the power is 1 here. After second stroke, the power is 2 here. Nothing else changes. N is n. This is number left. So you can generalize that. After n strokes, what will be left off? The number left, let's say n, nth n, whatever is left off, okay, will be equal to this n, capital V minus small v whole power n by small v, no, that's capital V whole power n. I hope you understand, just generalizing. Now that's all what we needed. So now I can say, so proportionality P final by P initial is equal to N final by N initial. This will give me P final is equal to P initial by N initial into N final. And this is my N final. I hope you understand. After N strokes, okay? So the P final will be P initial by N initial. What is P initial? P initial, I think it's just P, okay? By N initial is just N. N final, this is N final, so this N into capital V minus small v by capital V, power N, this N cancels off. So what I have is P final is equal to P initial is P. I can write as a whole power N. So I can write 1 minus small v by capital V whole power N. This is the final pressure. That's all. Oops. I hope this is clear. Okay, so that's all. This is the final pressure, and look carefully, pressure is decreasing. It's 1 minus something. So obviously the pressure, final pressure should decrease this 1 minus something and n times. Okay, so this is the final answer. I hope you understand the steps. If you have any doubts, post in the Telegram channel. 1 minus, there's no correct answer. Okay, you see this is clearly denominator is bigger. Okay, so denominator is bigger. I have 1 plus, there is no 1 plus. So this ulta, so here the denominator is smaller, the value is more, cannot happen. Okay, this is again numerator is bigger, the final pressure is greater than the initial pressure, absurd. Okay, so these two are possible. This is again the denominator is smaller, which means this value is way high. Okay, so which means the final pressure will become greater than initial pressure. That's also absurd. Okay, here the denominator is less, but that's not what the answer is. Okay, so there is no correct answer. And for the past few classes in the groups, there are some questions that are having no correct answers being posted. I don't know which book you are using. So if this is consistent, I advise you not to use that book. Okay, so this is correct. There are no errors in this calculation because you will be wasting time on problems with no correct answer in the answer choice. So even after you have solved it correctly, you will not be able to proceed. So don't use the books which have a lot of errors. Every book will have error, like 1 or 2 is advisable, but not in the entire book. You can have 1 or 2 errors. It cannot be like consistently you get questions where there are no correct answers. Okay. So see whether you understood the calculation. It's a logical one. And the answer is this. And here, unfortunately, there is no correct answer. Okay, hope this is clear. And if you like the video, hit the like button. Those who have doubts, you can post on the Telegram channel, link in the description. Watch the complete 11th and 12th playlist to get your doubts clarified. So keep practicing. All the best.